Write a table for the expression. Okay, there's two ways you can write a table on this. First way is to do it horizontally, okay? If you do it horizontally, x's should be on bottom. Yes. That's the way the book does it anyways. You don't have to, it's just more of a suggestion that you pretty much have to do, okay? All right, if you do it vertically like this, x's should be on the left. Now remember, x represents its position in the sequence, right? So we need at least 4 of these, okay? 1, 2, 3. And then the other one is the actual value of the term. Value. Okay, here let's just choose some values for x. Some really easy values like 1, 2, 3, 4. And this one will be the same, 1, 2, 3, 4. Those are very, very easy values to work with, okay? Now what we're going to do is we're going to use this expression to find the value of the term. So 4 times 1 minus 1, 3. 4 times 2 minus 1, 7. 4 times 3 minus 1, 11. And finally, 4 times 4 minus 1, 15. So someone give me a number. 5, 4, 12, 2, 7, 9. Okay, very good. All right, in this first example, this top one here, what we need to do is put an operation with it. And with properties, really the only 2 properties we're talking about are multiplication and division. So which of the 2 do you want, multiplication or division? I'm sorry, I said multiplication or division. I meant multiplication or addition. Okay, here's addition first, which means we'll do multiplication down here, okay? Okay. So here's the thing is, what we have to do is look at this. Okay, with properties, what we're going to do in this first one is we're going to change the order, okay? So 4 and 12 and 5, right? 5, there you go. Okay. And then this bottom one, what we're going to do, because everyone enjoys this so much, we're going to keep this order the same. Like this. Except for I'm going to put parentheses there. Okay? All right. So some of you have seen this properties before. Really with the 2 properties. Okay? So does anyone know what the 2 properties this is? Sam?
Is one of them the distributive property?
No. You're very close though. Sawyer. Yes, one is commutative and the other is Brigham? Associative. Very good. Okay? With this, all you've got to do, and you can pretty much ignore the parentheses, okay? All you're going to do is look at the order. That's it. If the order changes, the answer is commutative. All right? So if we were to look at this, this top one here, has the order changed? Well, let's look. 5, 4, 12, 4, 12, 5. Did the order change?
No.
Yes. It most definitely did. Okay? Since the order changed, this is commutative. Now, just so you guys understand this, and no one should have started on the homework yet. Okay, commute. Has anyone ever heard the word commute before? Yeah, a few of you? Okay. Commute is just when you go from one place to a different place.
It's like the commuter lane.
Yes, like the commuter lane, right?
Woo!
Right? So, the commutative property is where numbers commute. They go from one place to a different place. Okay? But in addition to that, it won't change the answer. They're equal. Right? And you could solve these if you really wanted to. 5 plus 4 plus 12, and then 4 plus 12 plus 5. You're going to get the same answer, okay? If the order does not change, it's associative, okay? Okay. Does everyone see that the order didn't change? What changed in the associative property? Yes, Ashley? Where the parentheses are. See, as it turns out with the commutative property, I can still use parentheses if I want, and I can move them. But the order did not change. So it's commutative, all right? Also, just a quick reference, please do not abbreviate associative. Again, though, just ignore the parentheses, all right?
Okay.
It's the order that you're looking for. All right, in first period, we kind of looked at this problem, but we found it to be extremely lame. So, but you can copy the answers if you really want to. Because I understand that the more answers you copy, the more joy you feel in your heart, okay? So, take a look at those and copy them down. All right, the commutative property, notice again, and you can see this with both addition and multiplication, that the order is changing, okay? With the associative property, the order do not change. Also, with the associative property, you should have at least 3 terms. Okay, you just keep that in mind. All right. All right. Let's look at this first example where it is 5. Okay. Well, 5 is never alone. Numbers never stand alone. Yes, that is correct. Okay. There are other numbers that are there, you just can't see them. Okay. Here's the thing is, what number would be with 5?
10.
No.
0. 1. Oh no.
Tanner? Very good. Let's look at this. Let's just look at that one for now, okay? So he says plus 0. Bam. See? Now it is definitely not alone, even though 0 has no value, okay? So it's a very lonely value. That is correct. It's the loneliest value, but it doesn't exist. Okay, so 5 plus 0, what would that give you?
5.
5, right? Which is what we started with, okay? So as it turns out, what we kind of compare this to is maybe you're looking in the mirror, right? And what would you see? Yourself, okay? And here's the other thing is, in math, since we have to make it complicated, we call it an identity. So let's say Morgan here, right? She has an identity. And if she looked in the mirror, she would see her identity. Well, it works the same way with this. This is the identity property. Identity. I think I spelled that right. Now, what's nice about the identity property is you can do it to anything, okay? Let's say that I took something like Tice, and I added 0 to Tice. What would I have?
Tice.
Yeah, no matter how much more you would want something better, you would have Tice, okay? Let's say that I took Colton up there and I said, I'm going to add 0 to Colton. Same situation, right? You get Colton. Okay, and that may not fill your heart with joy, but that's what you have, okay? What is something else that you really love? Ice cream. Let's say that I took ice cream and pie and added 0 to it. I would have ice cream and pie. Okay? That's all this is saying to you is that you can add 0 to anything. This means that you guys are never alone either. So when you're in a very dark room and you're thinking that the boogeyman is out there, know that 0 is with you. Okay? All right. So this is technically what we would call the additive identity. Okay? Yes, thank you. Additive, my bad. Okay. Additive. Sorry, the C snuck in there. Okay. Although it is still addictive, right? So it's additive identity. But I'm really not so concerned with you guys writing additive in there as far as properties go, okay? Just call it the identity.
Okay.
All right, well, some of you have already talked about this one. With 237, what other number would be with it? We know we can add 0, but there's another number that is with it. Morgan. Times by Juan, okay? Well, what happens when I multiply this by 1?
You get the same number.
You get, I know, some of you are saying, you get 1. No, you get 237, right? Okay, so this is 237. Notice it's the same kind of idea that worked with adding 0, right? So as it turns out, this is also called the identity property. But, of course, we have to make it more complicated than it really is. It's technically called the multiplicative identity. You guys know I'm not a big vocabulary guy, but unfortunately I do have to test you on the vocabulary for these, okay? Because it's technically not vocabulary, it's properties. It's still vocabulary, okay? But you do have to know these on the test, all right? So you please understand these, okay? Let's look at another example. All right, give me a number.
7.
Give me a bigger number. 27, that's fine. All right, here's the nice thing about any number. Actually, anything. If you do this with anything, just not just with numbers, all right? Let's say that I decided to multiply this by, I don't know, 0. Okay? What am I going to get? 0. Bam. This is so awesome that even if I were to take Sam's jersey and multiply it by 0, you would get what you started with, 0. Okay? That was pretty good, right? That was good. Right? Or Camden's shirt. If I took Camden's shirt and multiplied it by 0, I would have what I started with, 0. Okay?
That was pretty good.
Yes.
Even though I don't
That's
appreciate
good.
it.
No. Okay? All right. When you multiply by 0 anything, let's take 27, or as it turns out, there's a poster with many different examples over here. When you multiply anything by 0, you get 0. The pattern continues for both positive and negative numbers. Multiply by 0. See what you get. 0. All right? This one does have its own property name. And this one has many parts of the name. Okay? So it's multiplicative property. It's not finished. It's not finished. There's more. It's the multiplicative property O 0.
That's too big.
Is that better if it's smaller like that?
Do a dot and zoom out.
Yeah, I can make it really big too, see?
Oh my goodness. Yeah, but then you can't see it.
There you go.
I am.
Multiplicative property O 0. All right, these are the other 3 that you need to know. People are very, very familiar with the associative property and the commutative property, right?
Right.
But not really so. You're not usually very familiar with these 3, okay? They've given you more examples over here.
It's like Furniture Escape.
No. All right, name the property shown. Well, let's look at this one right up in here. All right, y times 7 equals 7 times y.
No.
Okay, well, what property would this be? Is there any 0s or 1s? No, so it has to be commutative or associative, right? So which one is it? Jess?
Commutative,
Why?
because it doesn't change the order.
Wait, say that again?
Tongue twisted. Never mind.
That's not an explanation. What happened here? Morgan? Yes, the order actually did change very much. Okay? Because look, right here the y is in front. Now it's behind. So it changed a lot. It commuted all the way from the front to the back. Okay? Look at this one.
I just know it.
Is there any ones or zeros?
Yes.
Yeah, it looks like there is, okay? So it's not going to be commutative or associative likely. Alright? Which one is it? 1 times c equals c. Eddie. Identity. Very good. Alright, let's look at this final example.
Holy crap.
5 plus quantity a plus 8 equals quantity 5 plus a plus 8. Okay. So, Ashley. Very good. Why is it associative?
Because the order doesn't change, but the parentheses do.
Very good. That's it. Order, no changing. Parentheses changing. Okay. All right. Notice all the book did was it showed the identity with it's the multiplicative identity with multiplication behind it. Okay, that's fine. Say whether the conjecture is true or false. If false, provide a counter example. Okay, this is a funny word. Counter example. Say that 3 times fast. Counter example, counter example, counter example. Say it 10 times fast. Counter example is any example, any example. Doesn't matter what the numbers are, as long as it proves it's one situation where it's false, okay? So notice this one, it says subtraction of whole numbers is commutative. Okay, so these are whole numbers. Hopefully you guys remember the classifications. Someone give me a whole number.
29.
7 and 29.
27.
All right, since it should be commutative and this is subtraction, we're going to see if this is equal to, we're going to commute 29 to the front now and see what this equals. So what is 29 minus 7? 22, right? What's 7 minus 29? Negative 22. So is this true or false? Subtraction of whole numbers is commutative. That's false. And we've provided the counterexample with these two. Notice the book right here also has given you another example. 10 minus 4, it does not equal 4 minus 10. Okay? So it is false though. Here's another example. 2, 5n. 2, 5n. Is the order the same?
Yeah.
Oh yeah, it's the same. So what property is it? Associative. Excellent work. Alright, here we go. A. Did the order change?
No.
Oh, it changed. So what property is it? What? What did you guys say? Commutative. I think I got that right. Okay. All right, B. What property is this? Jess. Very good. The identity property. How do we know that? Look, they even forced the 0 to disappear. It just disappeared. It became a phantom 0. All right, remember a counterexample is an example that shows that a conjecture is false. So the property does not apply. Really, it's all just this stuff, right? Yeah. There you go. Example, state whether it's true or false, and then provide a counterexample. So we're just looking at division of whole numbers is commutative, okay? So they've already given us example, 15 divided by 3. We're going to commute the 3 in front. Does it equal 3 divided by 15? No, it do not. There, 5 is not equal to 1/5. So it is not commutative. It's false. The difference of two whole numbers is always less than both of the two numbers, okay? In other words, is the answer always less than both of the two numbers?
It was bad.
I believe it. All right. Okay. Oh boy. What do you think it is, Ashley? True or false? False. So Ashley is saying that it's false. And what example did you counter with?
I did
37 minus 2, which is
35.
very good. Hold on, I just got to finish this, okay? Notice 35 is greater than 2, so it's not always less than both of the two numbers, okay? So that is good. Just with the book, they've used 8 and 2. And yes, again, 6 is greater than 2. All right, this is the part of the lesson that most people hate, right? Yeah, you thought that multiplicative property of 0 was bad. Just wait till you see that you have to start naming all these properties. Let me point this out, okay? These, you have to name each property that you're using for each step. Okay, so to simplify this, you've got to combine terms that either have letters. You combine all the terms that have letters and then all the terms that don't have letters, okay? So, for example, what we're going to do is, notice they use two properties here. So what they did is they used the commutative property by moving the G and the 7, which gives you this. And then they move the parentheses over right here. Okay? And you just do 7 plus 5, which gives you the 12. This would be your simplified answer. But in the process, you do have to name what you're doing. So this one was commutative. This one was associative. Then we simplified. All right. There is an easier way to do this. Yeah, I'm just going to commute the 5 over, and then I've got 5 plus 7 plus G. Well, now I just simplify. So that's commutative. I'm going to combine these two to simplify. Done. Let's look this one over, though, real quick. Notice it's 3 times C right here, right? So in other words, I can commute the 2 over. So now I'd have 2 times 4 times 3 times C. Okay? So in other words, I just combine these 3 to simplify. So I use the commutative property here. Then I just simplified. And I get 24C. Okay? Just real quick, right? Notice for this, I have 3 C's, right? Well, multiplication is just simplified addition. So I'd have C plus C plus C. Okay? But the thing is if I have to multiply this by 2, it gives me 2 of these. Well, that would be 6 of the C's. The problem is it's telling me that I have 4 of all of this. So 4 times the 6 C's gives you 24 C's. Okay? That's why the commutative property works in this case. All right, let's look at 3 then. So someone give me a number. 2. 5, 8. Okay? And since we're subtracting these, let's see how this works. I'm going to put the parentheses right here and solve. So 2 minus 5 is negative 3. Minus the 8 is negative 11, right? Well, let's move the parentheses without changing the order. So 2 minus 5 minus 8. But again, I'm going to move the parentheses right here. So 5 minus 8 is negative 3. 2 minus negative 3 is a positive 5. Is this equal to this? No, it is not, so this one is false.